Good evening. This is Assemblywoman Kadi Petrie-Norris. Thanks so much for joining us for our April Town Hall. This month, as we celebrate Earth Day and indeed Earth Month, we are diving into a very special and incredibly important topic, breakthrough innovations that are saving planet Earth. And I'm so excited to be able to welcome today 3 guests from companies that are doing work that is innovative, mind-blowing, and truly inspiring. So we are welcoming Lori Gaytree. Good to see you, Lori. Thanks for being here. Kevin Northcore. Hi, Kevin. And Professor Jack Brauer. Good to see you. So at last week's Earth Day Climate Summit, which was hosted by the White House, President Biden set a bold and audacious goal, pledging to cut America's climate warming emissions in half by 2030 as compared to our 2005 baseline emissions. That announcement has been met with a range of reactions. On the one side, we've got naysayers who say the timeline's unrealistic, who warn of the specter of rolling blackouts and massive job losses. On the other side, we've got incredible enthusiasm and people who say this is both doable and necessary, and that leading on the clean energy future really is critical to America's leadership and long-term prosperity. So we know this is bold, this is audacious. The timeline is significantly faster than our current goal. Just to start us off on our conversation, do you think this is achievable? Why or why not? And Lori, let's go ahead and start with you.
Sure. Thank you so much, Assemblywoman, and to the audience and for the opportunity to join you today. Do I think it's achievable? It's aggressive and needs to be all hands on deck, but is it doable between emissions reduction and carbon removal solutions like ours and others? I believe it's doable. We need to lean in, but it is possible to make it happen.
And Kevin Northcore, you are joining us from Amp Air Incorporated. Doable, realistic? What are your thoughts?
Yeah, I think it's necessary, I think is the first one. And oftentimes these goals are ambitious. I think depending on how you view them, some seem overly ambitious. I certainly think we need to be up for the challenge and to push ourselves in all aspects of industry to really change the status quo and to push communities, governments, companies to support achieving these big audacious goals.
And as you said, I think you said it's necessary, and necessity is the mother of invention. Right? So Jack, well, now we come to you. Professor Jack Brauer is joining us from UC Irvine. Thanks for being here. What are your thoughts on President Biden's ambitious climate announcement?
Yeah, I think it's definitely doable. And some would claim even not quite enough. I want to suggest, however, that a steady policy commitment and a strong investment in the diversity of technologies that is needed will lead not only to increased jobs, let alone reduction in jobs, but also the very dramatic reduction in price that will enable it to be not only achievable, but achievable at a lower cost than what we are currently paying for the fossil and polluting alternatives. And this is demonstrated to be the fact by the evidence we see from the investment and policy support we gave to solar, and that we gave to wind, and that we gave to batteries. And when we gave it to them, then their costs came down. And as a matter of fact, today, the cheapest way to make electricity is to make it from sun and wind power.
And we've seen incredible progress over the course of the last several decades. And I think one of the things that I think can be a challenge is for us to frame, when we look at the climate crisis, I think we often think about it as a multi-trillion-dollar problem, which certainly is, but it also really is, it's a multi-trillion-dollar opportunity as we navigate our clean energy future. And so excited to dig into some of that opportunity more as we move through the conversation. But I think the reason that I started actually with that question is that as I was reading articles over the weekend and reading reactions to President Biden's announcement, time and again, even folks that were naysayers, even folks that are saying this is not possible, did acknowledge that breakthrough innovations could change that conversation, could change our reality, and could make this possible. And so that's where all of you come in. And I'm so excited to spend a little bit of time just finding out more about the breakthroughs that your organizations are working on and are making. And I think we're going to start, Lori, with you. You are joining us from Carbon Engineering, and I know you and I first met, I think it was just a few weeks ago, when in a different forum, you and some of your colleagues came to share the work that you're doing at Carbon Engineering. And I was so excited when I came away. I remember I had my nightly phone call with my husband, and I was just buzzing and telling him all about your company. So excited to have you share some of that with the folks listening at home. What are you guys working on?
All right, well, I'll throw a few slides up on the screen to support the discussion. And I guess I should say that it does sound like magic to be able to remove carbon from the air. It sounds like magic, but it's not. And in fact, that's how we've put people in spacecraft and in submarines. We know how to scrub the carbon dioxide molecules out of the air. And the problem wasn't that we didn't know how. The problem was we didn't know how to do so at a very big climate relevant scale, and we didn't know how to do it at low cost. And so we did a few tons at a time, and it cost about $1,000 a ton. And that's how, if you watch the movie Apollo 13, that's how how they saved the astronauts, was by helping to get those air scrubbers fixed. The engineers were the heroes in that movie. So it was possible, but what Carbon Engineering has been working on for the last 11 years is that problem of doing it at really large scale and at very low cost. And to understand where the direct air capture technology, this breakthrough technology, plays a role in climate change, I just want to do a few slides on the carbon cycle. So level setting for the climate problem, and we all hear about climate change and concentrations of CO2. But what's happening, of course, with the climate problem is that the carbon cycle's out of balance. And so the previous balance between the sharing of the carbon in the active biosphere between the air and land and oceans got thrown out of balance when we discovered fossil fuels. And the good thing about fossil fuels, instant form of energy at very low cost, but through combustion, we add the CO2 up into the atmosphere. And we're currently adding about 4.5 million tons of CO2 into the atmosphere every hour, 4.5 million tons. And a ton is about the weight of a small car. So massive amounts of CO2 being added, and it's thrown the carbon cycle out of balance. We're up at about 412, 416 parts per million today. We need to do something to reduce the concentration of CO2 in the atmosphere. And if we look at it just from, we can measure the concentration in the atmosphere, and pre-industrial, we were at about 280 parts per million. We've gone rocketing up to about 416 today. And when we hear people talk about 1.5 degrees of warming or 2 degrees of warming, what we really mean is that we continue to add CO2. And when we get to 430 parts per million, which is about 7 years from now at current rates, then on average, we're at 1.5 degrees of warming. So we can measure the CO2 in the atmosphere. We know how much we're adding. We're predicting this. And so what we're trying to do is slow down and ideally stop new emissions from happening. And there are also ambitious folks around the world working on something called climate restoration, which is hoping to be able to start to not just get to net zero, stop adding a new tons of CO2, but also go backward and start to draw down the excess CO2 that we have in the atmosphere to get back to safe levels, which are considered to be 350 parts per million. So, so the problem is just something we measure: too much CO2 in the atmosphere. What's missing? Well, we need to do our best and reduce the rest. And so we need to reduce emissions everywhere we can, but also we need to start to remove carbon. So if there's 1 ton that still goes up, we need to take 1 ton out and permanently remove it from the active biosphere in order to get to true net zero. And so this technology we've been working on, direct air capture, we see as the technological missing piece. So one more tool that we've got now in the climate toolbox, where we can do so affordably. We can actually remove carbon from the atmosphere at scale and affordably. It essentially has no limit. So there's no limit to the renewable energy or the geologic storage. that we have on Earth to be able to remove those emissions permanently. And it also allows us to deal with the legacy CO2 that's been building up in our atmosphere, which is actually about 95% of the problem. So we're excited to be bringing this new technology to market. We're deploying it now at commercial scale. And this picture here is a rendering of our final step up in scale, which is for us a 1 million ton per year. So with this project, we're over 50,000 hours into the design of this project that will deploy actually in Texas, and it will remove 1 million tons of CO2 from the atmosphere. And it will be a blueprint to build out this clean infrastructure across the US and across the world. We know to solve climate change then that we must reduce emissions, remove remaining emissions for anything we can't offset, and remove those legacy emissions. But what do you do with those CO2 molecules to make it economic to build out this clean infrastructure? Well, the answer is we can either put them to work in carbon products, or we can remove them permanently from the atmosphere. And when we put them into low carbon products, one of the good places for us to put those carbon molecules to work is to turn them into fuels, so that we can burn them. For instance, in hard to decarbonize sectors like aviation, we can create a low carbon jet fuel, so ultra low carbon jet fuel. And in that case, the CO2 is going to go through the combustion again, but now we're recycling the carbon from the air instead of having to pull new fossil fuel out of the ground and add that carbon into the air. And one of the what's valuable in the low carbon fuel under a low carbon fuel policy like you have in California is what you can't see, which is the ultra low carbon intensity of the fuel. But there are co-benefits when you create a synthetic fuel like this, such as a lack of sulfur and particulate matter and aromatic hydrocarbons. So it burns really cleanly. So there are those air quality co-benefits that come with the creation of those low carbon fuels. So that's one place we can put those CO2 molecules to work. And then of course, there's just simply permanent removal. So we can take it out of the active biosphere and safely and permanently put it back into the geosphere. So two good uses for those CO2 molecules. And with that, with direct air capture being that new technology, it's complementary to all of the above. We need an all of the above approach to solve climate change, complementary to wind and solar and all of the other good ways that electrification, all of the other ways that we're working to solve climate change. It's a new tool in the toolbox that we're deploying now that will be able to help us to restore that carbon balance. You know, in California, we work with governments around the world, and in California, you have world-leading carbon policies already and an ambition to get to net zero. And so we're really excited to be working with teams in California, looking at places where you can deploy both this air-to-fuel technology as well as that carbon removal technology and create those jobs at home as you decarbonize. Oh, Assemblywoman, you're on mute.
It wouldn't be a Zoom call without that being said at least once, right? So you mentioned that you are currently constructing and about to launch this plant in Texas. So when is the go live date on that project?
Construction begins late this year, early next year, and then it will begin removing carbon in late 2024.
So it's not tomorrow, but it's imminent and just around the corner. And just to help put in perspective what you're doing. So I think you said in the Texas plant would be capable of removing 1 million tons of CO2 per year. When you all think about sort of the vision for direct air capture and how we make that, as you said, climate relevant, how much CO2, how many tons do we need to be removing per year as a goal, big picture for your company and for the industry more broadly?
Yeah, no, great question. The world emits about 40 million tons of CO2 per year today, and that's about 51 million, billion tons, gigatons, million tons. So we emit 40 gigatons of CO2 per year. By 2050, climate scientists believe that we may need to remove 10 to 20 gigatons through direct air capture to help us get to that net zero mass. So that would be 10 to 20,000 of the projects in behind me, that 1 megaton plant. So we've got a lot of work to do in this. So that's why we see this 1 megaton plant as just a building block that will be deployed across the world where we have resources like wind and solar to power the plant. and either a demand like a liquid fuel market or those geologic reservoirs where we can put the CO2 back safely underground.
Wow, fascinating, really fascinating. And we'll come back. We've got some questions once Kevin and Jack have shared a bit more about the work they're doing. We'll come back with a few more questions. But I think with that, Kevin, we'll go ahead and turn it over to you and tell us about the work that you're doing at Ampere.
Great, thank you, my pleasure. Let me share my screen here. All right, 5 years ago in Southern California, we founded a company named Ampere with a big vision for sustainable aviation. Lori, mentioned a few things that piqued my interest. One is that these breakthrough innovations sometimes seem like magic. And I have a quote that I love from Arthur C. Clarke, a sci-fi author, that any sufficiently advanced technology is indistinguishable from magic. And I think a lot of what we do here, whether it's electrified aviation that I work on, or pulling carbon from the atmosphere, or many of the other truly game-changing innovations that we kind of see happening around the world, are happening because people feel deeply that it's needed. There's a strong mission component. And I think if you can find those very meaningful and challenging opportunities, then and if each of us were contributing in those areas, then we really would be able to hit these big audacious goals that we all have. So at Ampere, we're focused on one of the hardest to decarbonize industries, aviation. And aviation is particularly difficult because in order to fly, you have to be very lightweight. Really, hydrocarbon fuels have been the only solution. The industry, because safety is so paramount, struggles to adopt new technologies readily. And so all of these come together and make it a big challenge, but this is one that we're taking on because we believe it is just so meaningful. The key is not just to have a vision for sustainable aviation, but it's actually to bring electrified planes to market, to sustainable aircraft to market, that also bring real utility, that solve the problems in regional air travel, not just business jets for ultra wealthy, but the kinds of planes that would affect all of our lives. And so before diving into the technology, I'd like to just kind of pose a question of what the world could look like with sustainable aviation that was lower cost, lower emission, lower noise, where the municipal airports around our homes were assets to our communities rather than burdens. Here in Los Angeles, we've got an airport, the Santa Monica Airport, is getting shut down because people don't see the airport as a benefit to the community. It's the noise and the pollution. It's more of an annoyance than anything. That's such a shame that a transportation opportunity, a jobs building opportunity, an economy building opportunity is ultimately not all that great of an opportunity in its current form. So we think about, what if we could apply electrification? Well, one of the key factors of electric or electrified airplanes is that the operating cost is quite a bit lower than the combustion alternatives. So what this means is that you can actually deliver a more affordable type of aviation to people all around the world while also reducing those emissions. Affordability means that you can fly more routes to more places, connecting more communities, and maybe even giving people something they can dream about, different ways that they can engage with flight that maybe they thought was always out of reach. Ways that maybe we would have to charter an expensive plane in the past, but now the everyday person would be able to afford it when it goes electric. So reducing those stresses and reducing the major burdens. So what we're doing at Ampere is we're building a scalable electrification platform, the EV technology, that integrates into many planes and gives us a scalable solution to decarbonize aviation. We're beginning with hybrid electric planes, so fully electric challenges with the lithium-ion batteries and the energy density of those. So enabled by technologies like synthetic aviation fuels or other sustainable fuels, paired with the electrification technologies, we're able to architect planes that really have the utility to fly between these airports. We got a few principles that we really think will make this worthwhile and viable. Number one, to integrate into existing regulatory structures. That is because the aviation industry is so challenging to bring new products to market, working within the existing expectations, safety expectations and regulations is very important. In addition, there are so many airports around the United States. I think it's over 70% of flights go in and out of 30 airports, yet there are 5,000 airports that are available for commercial operations. They just don't get used because it's not economically viable to operate to those routes. But we're able to operate within that infrastructure, and similarly, we're able to be resilient to technology change, enabling us to get to the fully electric solution that we all believe in, and ultimately scale up to those larger planes and longer routes that we all know as the commercial aviation. We don't just talk about this though. We've been doing it. 2 years ago was our first flight. It was the world's largest hybrid electric plane. We've been flying ever since. Last fall, we deployed an aircraft, this plane that you see here, out to Hawaii to fly on twice a day round trip airline routes in an experimental market survey category, first in the world for that as well. Really proud of what we're able to demonstrate, the true benefits of sustainable aviation. Of course, reduced fuel burn, reduced noise, but also utility. It's a useful plane. We were able to fly, longest flight was a little over 340 miles, longest endurance over 3 hours. So these aren't just fanciful ideas. It's really something that can be applicable. Now, this is a 6-seat plane, and when we took it to Hawaii, we were flying those round trips out on the island of Maui, just a really tremendous and wonderful application. But we see this as an opportunity to scale into commercial applications. So these regional airlines and larger, offsetting those larger planes, giving the same per seat economics of a 50-seater that you can then operate at a hybrid 9-seater. So we're dreaming of a future here, but we're doing real things along the way, beginning by upgrading existing planes to hybrid electric, working with aircraft manufacturers to help them deliver sustainable versions of their planes as well. And of course, dreaming of the clean sheet designs in the future, which will be fully electric and sustainable through and through. And so that's really what we're focused on here at Ampere, is building a future that might seem magical, certainly feels breakthrough, and is full of meaningful and challenging opportunities for us all.
Yes, you certainly like to scale big hills, don't you, Kevin? That's incredible. So what were you doing before you decided to establish and run Ampere, and before you had that vision?
Yeah, so I got my mechanical engineering degree at Caltech in Pasadena, California. All my research was in robotics at NASA's Jet Propulsion Laboratory. And I picked up a pretty exciting job at Northrop Grumman, where I spent 7 years starting as in research and development for engineering, and then growing into kind of the program management part of the house, both in airplanes as well as satellite systems. And I think it's when you see the impact that you can have on these major programs, but then also one of the programs that I worked was a weather satellite, an Earth observing satellite looking at the atmosphere. And one of the things you look down and you actually notice ice caps retreating. I mean, you see these things, and I've always felt that I had this deep awareness for the environment, the ecosystem. I grew up in Utah, so clean, fresh air, blue skies were kind of my thing. And I feel as if this is one way that I can do my part in making the world better.
Well, and one thing that I just think is so amazing is I think, honestly, sometimes the scale of the climate crisis we're facing, I think both for experts and for just the average person, it can feel incredibly overwhelming, right? The challenges can feel completely insurmountable. And I love it that we have these climate entrepreneurs like you and like so many others across the great state of California who really believe that you can be part of the solution to the greatest challenge of our generation, and that you are working so hard to move the needle in a really meaningful way. I think it does, in many ways, it kind of typifies, sounds like you're born in Utah, but it sounds like you got a lot of your bona fides here in California with some of our best institutions and most innovative and groundbreaking companies. So it kind of, to me, sort of typifies the spirit of California innovation and adventure and real hope. So excited, as I said, to ask some more questions as we move further into our discussion. But with that, let's go ahead and welcome Professor Jack Brauer. So Professor, you are the director at the UC Irvine Advanced Power and Energy
Program.
Site Program. Thank you. Tell us about the work that you and your colleagues are doing there.
Thank you very much for this opportunity. Yes, we do a lot of research on solar and wind power, and especially on the technologies that must complement them in order for us to achieve 100% zero emissions. And this is an example of a simulation we made for the entire state of California to make it through the year using only renewable electricity from sun and wind power. In this particular case, we assumed a wind dominant case that has 37 gigawatts of solar capacity and 80 gigawatts of wind capacity installed. But you can see at every hour of the day, going all the way from January 1st through December 31st, we either have a deficit of wind and solar power indicated by all the red data that you see here, or a surplus of that solar and wind power as you see in the blue data. And the good news is that we have plenty of land and plenty of resource to actually make it through the year. And as a matter of fact, this shows that we actually have way more surplus in this given year than we have deficit. The only thing we need to do is to move it around at different times of the year. And the way we do that today is with pumped hydro. And we have a very big pumped hydro system, but you can see that the height of this indicating the amount of power that our pumped hydro system could take if we could turn all the pumps on at once, about 9 gigawatts. That's pretty big. And if you look at the size of the lakes that we have associated with pumped hydro, you can see that we have almost a month's worth of that 9 gigawatts, which is a very big energy storage system. But it's actually quite insufficient for a 100% renewable California. Many people think that we could use lithium-ion batteries and have suggested that we could use our cars. Maybe we could just use our cars to help support the electric grid of the future. If we converted all of our light and medium duty vehicles to electric vehicles, this is how large the resource would be if they had a battery the size of a Nissan Leaf. It could add a lot of power capabilities, but not much energy. And this is one of the challenges associated with lithium-ion battery technology. It's wonderful, and we must use it in cars. I suggest here, though, that it could help us only in daily shifting, not in the massive amount of shifting that we need for a 100% renewable grid. And that's where some of the technologies that we're investing in quite a bit lately come into play, like renewable hydrogen. Because if we just converted our current gas system to use renewable hydrogen and store it in existing facilities, not build a new one, just store it in existing facilities, this is how big the resource would be. It's the only resource that is grid scale and the only resource that is enabled, that could enable seasonal levels of storage to move the excess surpluses we have in the summer to the fall and winter months. So this is one of the reasons we need both batteries and hydrogen to achieve our zero emissions future. And we're looking at how can we transform this gas system that's currently delivering fossil. And we're looking at lots of different research tasks associated with that. But one of the ideas we had was to see if the pipelines could handle the pressure, literally, the pressure dynamics of making renewable solar hydrogen and putting it into the pipelines. So we did a simulation of installing solar in exactly this square area that you see here on the screen, 20 miles by 20 miles. That's a very big solar farm. And then if we closed the valves here, just turned off the fossil that's coming into California from Louisiana and Texas. And then we put all the solar power here into hydrogen and just use these pipelines to deliver it to the rest of our communities. And what we found is that those pipelines could actually easily handle all the pressure dynamics, which you see are primarily daily, going up and down every day, well within the pressure limits. And just this one project, 20 miles by 20 miles of solar, could add 40 points, 40 percentage points, more than doubling our current amount of renewable energy in California. This is just because the gas system is such a massive resource for zero emissions. In addition, if you have an end use that requires one of any of these three things, rapid fueling, long range, or large payload, then hydrogen is a zero emissions vector that might be useful. Certainly batteries and fuel cells plus hydrogen are the majority of these heavy duty applications that we expect in the future. In addition, there are some end uses that haven't been focused on too much lately, like the manufacturing of cement and steel and plastics, ammonia, computer chip, and some pharmaceuticals. These kinds of applications are difficult to electrify, but they can be electrified by the hydrogen vector, meaning we start from renewable sun and wind power, and we make hydrogen out of it, and it can be used as a feedstock, as a reducing gas, as a high temperature fuel for some of these difficult to electrify applications. And we're fortunate here at UCI to have research projects that are addressing these very difficult to electrify applications. Thank you for your attention.
Well, thank you, Professor. Let me just ask you a couple questions before I kind of open it up for a broader discussion. So what you just described for us, is this, what stage is this? Is this kind of still proof of concept, or is this, we have proven what you had on your slides and we should be ready to implement it, and as policymakers, we should be ready to get the ball rolling? Or where are we on that kind of life cycle?
Well, since I mentioned so many different applications, there's a broad spectrum of technology readiness levels associated with the ideas I presented. Let me suggest that the idea of making hydrogen from renewable sun and wind power is at very high TRL already. The main challenge with electrolysis, this means by which we can take renewable electricity and make hydrogen from water and that renewable electricity, is very proven technology. But unless we have a larger market, we can't bring the cost down to make it competitive. So from my perspective, that is a policy decision primarily, and a policy decision that has been made in the positive sense in many jurisdictions. Let me go to another set of research challenges that have a lot of room for research before I can prove this can be done. So for example, converting those pipelines that go from Blythe to LA to transport hydrogen, there's a number of research challenges yet there. That's very low TRL, but we have done it on our campus already, showing that it's at least possible to mix fractions of hydrogen into our campus natural gas system, partially decarbonizing it. But that's not the end goal. We have to completely decarbonize it. And that requires some research and development still. And then there are many things that are in between, like, for example, hydrogen fueling infrastructure is very nascent, but it's proven technology, again, costly because we have so few of these fueling stations around. So battery electric vehicles are preferred with this circumstance. But eventually we need a combination of those battery electric and fuel cell electric vehicles to meet the variety of demands. Like I said, if you have a short commute and you don't mind charging for a while, batteries should be your preferred option. If you have a heavy payload and you got to go a very long distance, hydrogen might be a preferred zero emissions option.
And let me ask you another question. And actually, I'd like to ask this question for all of our guests. So what is the one or two kind of most critical challenges, or the most critical hurdle that you face right now before kind of that vision can become a reality? It sounds like, one of them, it sounds like, is cost, which you believe can be somewhat addressed by scale. Is that correct? And what are the other sort of big hurdles right now that need to be overcome in order for this to be really and truly a breakthrough innovation that can have its climate scale impacts?
So let me suggest that a firm policy commitment, which is one of the things I stated in response to your first question. If the policies are established to engender zero emissions and resilient zero emissions in all applications, then we start to actually have investment, both private and public investment, in the appropriate technologies to actually achieve zero emissions. And that's what brings the cost down, because the scale of this problem is so huge that it will garner sufficient investment to actually bring these costs down. Again, proven by what we have invested in with a policy and investment strategy for solar and wind. And I would suggest that if you look at European, Australian, Japanese, and Chinese policies and investments in really achieving zero emissions, that's where you see these sorts of things taking place first.
And let me come back, Lori, to you. What's the one or two things what's the biggest hurdle right now for carbon engineering?
So simply policies. So carbon markets that place a value on decarbonization, and the California Low Carbon Fuel Standard is already there. So both the low carbon fuels we can produce with that atmospheric carbon combined with green hydrogen, and also the permanent carbon removal. Both of those are recognized by the California Low Carbon Fuel Standard. But and Washington is actually just passing a low carbon fuel standard and following suit with California. Here in British Columbia, where I am, we have a low carbon fuel standard that followed California. But those are nascent. This is a nascent market, and what we really need is carbon policies around the world that allow for decarbonization with a direct air capture solution, which is already a lot less expensive than many things that we're already investing in to decarbonize. And in fact, when we step way back and people ask, can we get to net zero, and is it affordable to get to net zero? We actually know how to get there, and it would cost about 8% of global GDP today to get to net zero. So the good news is we know how to get to net zero between emission reduction and removals. The bad news is it's 8% of GDP, which is unaffordable. But when you add direct air capture, we actually cap the cost of getting to net zero, and we bring it down to about 4% of global GDP, as long as carbon policies and markets allow for that as a solution in the toolbox. So because we're so new as a solution in the toolbox, carbon policies are catching up. And then as those carbon policies are put in place, it'll bring a market that'll let us build it out, and we can build out this infrastructure as fast as those policies pull.
And Jack mentioned a couple of countries that perhaps are doing better than the States in terms of setting policies and both policy commitments and also backing that up with investment on the hydrogen side. Or are there specific examples around the world that we should look to and that you'd point us to in terms of who's leading the way on this globally?
Honestly, I usually point the world at California. So that's
that's good to hear.
That's carbon, California's way ahead. I would say in terms of global policies that are looking at other different ways to help. There are some countries that are looking at what's called carbon takeback. So having the government also procure direct carbon removal to offset some of the government emissions. For instance, government employee air travel could be a new kind of market, could be not just through a low carbon fuel policy, so that low carbon fuel rewarding the carbon intensity, but also just a simple carbon take back. Now that we can do carbon removal at scale, sourcing, just purchasing the carbon removal to offset government emissions. So that's one additional kind of policy that we don't see yet in California that's being done elsewhere. But otherwise, California is already leading the way. So keep going, and then add in more hydrogen. And for us, to create those low carbon fuels, we're actually taking carbon out of the air, green hydrogen that we've made from electrolysis, and combining them, and we make those long chain hydrocarbons, so synthetic fuels that are drop-in compatible from those two. So if you advance on hydrogen, that also helps with that particular kind of utilization of atmospheric carbon.
And Kevin, kind of what is the number one hurdle? You laid us out, you laid out kind of where you are today, tomorrow, and the future. What do you need to have happen to get to that future?
So I think there are a few big steps that could help. First is when people consider sustainable transportation, aviation should be included. And whether those are the policies that currently are limited to, light duty, mid duty, heavy duty, ground vehicles, or other forms of transportation, oftentimes if you were to look through those, aviation isn't listed, and that ultimately leads to a more limited resource set and tool set to go support the solutions here across the board. And so just ensuring that anytime a sustainable transportation or mobility solution is discussed, let's just make sure aviation is in there. That's the first one that really just is about opening the door and inviting us to be at the table in those conversations. We're seeing that begin. And we are seeing an increased interest and focus in the area, but it's still relatively early and quite a bit of change in the kind of inclusion in the policies. The second is, as we mentioned before, aviation is a highly regulated industry and very, very challenging to decarbonize. And the reality is you should not lighten the regulations. We need planes to be ultimately safe, right? But this is a challenge to bring new technologies into the industry. And if we're expecting the FAA to move rapidly in adopting innovation, then it's not by lowering the boundaries or the barriers, it's about increasing their resources. And whether that's the support directly of the FAA and increasing the kind of certification and technology type resources that they have, or other additional funding to groups like NASA, who are working on the core technology and also supporting the broad-based knowledge within our industry base here in the States for how to develop and deploy safe new technologies, sustainable technologies. I think that those are two areas that are could really drive positive benefits and accelerate the entry into market for us and for all sustainable aviation solutions.
Well, I think just coming back to the first point that you made, that oftentimes when we're talking about sustainable transportation, aviation is not included. I think that is because a lot of people just assume it's impossible, right? I think a lot of people just accept, okay, let's get people into their zero emission vehicles. Let's try to electrify the large fleets, but people just don't think it's possible. We kind of almost accept that we're going to have a certain amount of air traffic that is just not part of our clean energy future. And so I think the more I think that both policymakers and other stakeholders actually, I think, believe what you do, which is that this can be part of our clean energy vision. I think the more that we'll see that start to happen.
Absolutely. And around the world, you're also seeing big moves in these directions. I mean, I spent some time out in Norway, and they made an early commitment to take all of their domestic air travel fully sustainable. But then you just look, I think it was a week ago, maybe two, where France said that they're cutting all the regional flights. And I think it was under 200 miles. Any regional flight, they would be stopping those flights and saying you have to use a more sustainable ground transportation. And the reason you cut those flights is because, well, there's just no solution out there for those. Yet, this is what we're building. We're literally building the airplanes that will carry people in a sustainable way 50 to 500 miles, with that sweet spot in the 50 to 250 mile range, exactly where France is cutting those flights. And so what we see is that sometimes you just want to throw your hands up and say, we're done, but maybe investing and looking, keeping your eyes above the horizon and seeing these new technologies coming in, we can be part of that solution too.
Yeah. Well, and I think time and time again, right over the course of human history, there are so many things that seem absolutely impossible until they're not, right? And when you look back at the course of the last 20 years and the acceleration of technological innovation, even just over the last 2 decades, many of the things that we just take for granted as products of our daily life seem pretty inconceivable and impossible just 20 years ago. I want to actually ask a quick question, Jack, of you, because I know it's a question that's come up both when I've been talking to constituents and when I've been talking to other legislators and policymakers, and that is around hydrogen as a clean fuel. And I know, I think, Laura, you used the phrase green hydrogen. So there are some folks, Jack, who say, oh no, when we talk about our clean energy future, we're talking about, and it's all electric. That's the only game in town. Hydrogen's not clean enough. Can you explain to us why that is not correct? And why hydrogen needs to be one of the tools in our toolbox?
Yeah, let me suggest that in some applications, I agree. If you look at, for example, residences, especially new residences, whether they are made in apartment complexes or individual homes in communities, a better way to design them from the get-go is to make them all electric, to have them also put in solar locally and have some battery energy storage locally, and to meet their thermal demands with heat pumps. They have a coefficient of performance that adds to the benefits of using electricity to produce thermal energy. So in some sense, I agree with that kind of a statement. It's better to electrify. But then when you get into different scenarios, other than the one I just described, like some of the industries I talked about, like some of the freight that has to be moved around in society, like some of the dense urban environments that can never install enough solar in the dense urban environment to come close to meeting all the thermal plus electrical demands. And then that requires then the wind and solar power to be outside the urban environment. And then you have to figure out, okay, well, how am I going to get it to them? And how am I going to store all of that in a seasonal way? And that's when it gets to eventually 100% sun and wind that's outside of the city and has to be brought into the city. And it's always going to be more resilient to bring it in both wires and in pipes. It's also going to be less expensive because the pipes and corresponding infrastructure already have that inherent storage capacity. And so you start thinking about, oh, that starts to make some sense to use it for that purpose, to get the grid to 100% renewable. And then you start to think about the things that Lori Gatry is talking about, right? How do you make a sustainable aviation fuel that can actually do the cargo planes and do the, 1,500, not much longer transport than Ampere is doing, and things like this. And you start to say, oh, the hydrogen is an input to that fuel production. Okay, so renewable hydrogen can play in that too. And then you start to look at other things that are already adopting hydrogen for business purposes because of its rapid fueling feature. So for example, forklifts in major distribution centers. Why are they adopting hydrogen as a zero emissions option? It's primarily because they can keep their fleets going 24/7, because these are 24/7 operations at these Amazon distribution sites, okay? And so you start to see various features of hydrogen that complement the features of batteries, which are better in some applications, and which complement the features of renewable solar and wind, allowing massive storage and seasonal storage and resilience in underground delivery. You put these all together and it says, aha, that's why we need hydrogen in addition to batteries, solar and wind. And let me make a point. If you only want to get to 50% renewable, you don't need hydrogen. It's better to just use batteries, okay? Because you only need a small amount of storage and you're going to do this. It's when you start to get these other things, when you get really close to 100%, that's when you start to need it. If you want to decarbonize everything, that's when you start to need it.
Got it. Okay. And one question I want to ask to all of our panelists before we have to wrap up is, other than the work that you're doing with your organizations, what's another breakthrough technology or innovation that really excites you today? Kevin, let's start with you.
Oh goodness. Well, it's a shame that Lori's here, because I would have said pulling carbon from the atmosphere and making sustainable aviation fuels. I'm a
Awesome.
deep believer in building ecosystems of solutions, and that it's a yes and. There are many things that need to happen, and I think that's just magical. I love it. I think that it's a wonderful solution if it can be done in a sustainable way, and like all the challenges can be resolved economically. I think that's great. I also happen to be a fan of space exploration, and so there's a whole stuff that's happening up in space that can help us down here on Earth, and I'm pretty excited about that too.
Is there, see, that might be the subject for a whole nother conversation. I was going to ask you a follow-up. It sounds like that's probably more than a 5-minute answer, Kevin. All right. So add space exploration to the list of breakthroughs. And Lori, what are some other exciting technologies and innovations that get you fired up?
We've already talked about hydrogen and electrification. So those would have been two of the big ones that I would have talked about. So I would say breakthrough thinking, really thinking about net zero. Like, it's hard to wrap your arms all the way around net zero and then come up with a plan. And I want to give a shout out to the Lawrence Livermore National Lab. The California has an ambition to get to net zero. And the Lawrence Livermore National Lab said, okay, we have policies in place that get us 80% of the way there. What are we going to do for the last 20%? And so they published a report last year called Getting to Neutral. And they truly said, to get to net zero, true net zero here in the state, this is what we recommend. We've looked at all the opportunities to reduce our emissions and remove carbon, and here's what we recommend. And so they wrap their arms all the way around net zero. And the recommendation said, not just this is what we should do, but also we can create these jobs at home. So here's how we can build out this clean infrastructure and not just have to import solutions from elsewhere. We can actually create that economic development and the jobs at home. So I'll give a shout out to the big, bold thinking about how to get there and real solutions that are implementable and create jobs.
And that is such an important part of the conversation, I think, when we're having this discussion about California's and America's clean energy future. We have to make sure that jobs are not an afterthought, right? And that the jobs are at the forefront. And already, as I'm sure all of you know, and actually many folks watching at home may know, California, we've already got, I think it's something like 5 times as many clean energy jobs as we do fossil fuel related jobs. And we are just at the beginning of a tremendous period of growth in that sector. And we want to make sure that California is positioned to continue to be a leader, to continue to have those innovations grown here in California, to have companies start here in California, and to have those jobs here in California. And we've got to make sure, again, that they're good jobs and that we're replacing, because we all know the fossil fuel industry, those have for years and years been a path to the middle class. And we want to make sure that as we're creating clean energy jobs, that those are also good, high quality jobs, which is so key. So Jack, other innovations that you're excited about?
So I can't believe Kevin gave that answer, because that was going to be my answer.
Tell us more about it. Tell me more about it.
Let me just mention a couple of things, because it is quite remarkable to make a long chain hydrocarbon out of carbon that you capture out of the air and renewable hydrogen. Okay, it's an incredible technology, and so what Lori Gatry is doing is incredible. And aviation, like you said, it was considered one of those transportation applications that might be impossible to electrify, and here Kevin's doing it. Okay, so this is pretty cool. Let me mention a couple of other things though that kind of impressed me. One of them is electrochemical means of doing what we used to do all with thermal and fossil. And so, for example, when you have to make steel, or if you have to make ammonia or cement, and these things that people also thought maybe we can never decarbonize. We have to have coal. We have to have the features of coal, okay, to make steel. But I think that's not any longer the case. We can make steel, and we can make it with renewable hydrogen. We're fortunate to have a Department of Energy award in that space, but lots of people are the experts at doing that. We are not. We're just going to make the hydrogen for them. But another thing that I'm very impressed with, and again, I know that other jurisdictions already have policies in place and some funding in place, but the Biden administration's plan is actually very progressive and consistent with all these other jurisdictions that I admire, okay? And California has been a leader too. I would suggest not as great a leader in the hydrogen space as some of these other jurisdictions, but this is just going to happen over time because I'm so sure that hydrogen is going to play a big role. I do want to mention one other thing because I think that equality of benefit and addressing the severe consequences of our energy conversion technology on disadvantaged communities has to be included. And again, the Biden administration is to be admired for including this explicitly in their plans, because the majority of the emissions that come from our consumption and our energy conversion fall upon a few, primarily air quality impacts on the few that live next to ports, that live next to industry. And this is a very, I don't do research in this area, but I admire those who keep pressing this and who are making it a policy priority, okay, to do this. Because these technologies should benefit all people and they have a chance to change that paradigm of disadvantaged communities.
Well, and thank you so much, Jack, for highlighting that. It is so true. And you're absolutely right. We have an opportunity to ensure that this transition to a clean energy future happens in a way that uplifts all Californians, particularly our most advantaged communities. But we also know that none of that happens without intention and without strategies to ensure that we make that so, right? We can't just, wish for environmental justice and have it be so. Right. I appreciate your point that it's folks that are turning that goal into practical asks and into practical policy proposals that are playing a really critical role as well. Well, I want to thank all of you again for being here. I so enjoyed talking to you and learning more about what I just really think is the fascinating work that you and your organizations are doing. So thank you so much. And I think Lori, you and your I think in one of your first comments, you mentioned the movie Apollo 13. And you said that the engineers were the hero in that movie. I think as we look at our world today, the engineers are the heroes in our real world each and every day. And it's so inspiring to hear about the work that you all are doing and the breakthrough innovations that I really do believe are going to position us to both hit the goals that Joe Biden has set out for America and also to combat the climate crisis and confront, as I said, I think at the beginning, really and truly the greatest and most profound challenge confronting our generation. So thank you again for being here, and thank you to everyone at home for joining us, and look forward to seeing you next month for our May town hall. With that, have a great evening. Be safe and stay well. Bye, everybody.